Okay, I'm going to go over the chapter 4 quiz. I know last time my audio cut out partway through. I don't know why. I'm considering getting a new webcam just so that doesn't happen again. But I will check this one and make sure as I go through. So let's just jump in. First, we're going to start with naming the molecule shown below, the one in number 2. So I'm going to try to address some common problems I saw when I was grading this. And one I saw a lot was that students would try to start with the alcohol as number 1, like they'd number 1, 2, 3, 4, 5. And that's not correct. The parent chain is made up of carbons only. So actually, the first carbon, 1, 2, 3, 4, is the main parent chain. So that's only 4. So the main parent chain is butane. And then the other thing I saw, so I'm going to highlight this main parent chain right here. The other thing I saw is people would find the butane, but then they would try to name like this as an ethyl group or something. But once you've named a carbon as part of the parent chain, you don't have to name it again. You only name each carbon one time. So you've named it as part of the parent chain. It's contained in the parent chain. So that's it. We don't have to name any substituents off of the parent, like that are part of the parent chain, because you've already counted those carbons once. But you do have to name any substituents that aren't technically named in the parent chain. So if we just write the word butane, we just have these 4 carbons, right? And then the things that we're not seeing present here is this OH and this I. So then that's the next thing we have to do. We have to name these substituents. So in that OH, we're going to number carbon 1, and the suffix for that is OL. And then I is at 2 iodo. And if you didn't quite get the iodo, if you're like 2 iodine or whatever, I was generous, and gave you credit for it, but it is iodo, just like fluoro and chloro. So let's say let's combine this all. So we have 2 iodo, butane, and I changed the colors just so you could see where it came from, butanol. So that's the full name. And one thing I want you guys to practice is actually going from the name back. So if you're ever not sure, so I saw a few people that they named it pentan 1-all. They named it 3 iodo pentan 1-all. So if that is what you named it, then to check yourself, draw the pentane. 1, 2, 3, 4, 5. Pentane is 5 carbons, right? And then 1 alcohol is OH right here. And 3 iodo would be 1, 2, 3 I right there. So if this doesn't look the same as this, so you can compare these two. So practice going from the name to the what's the phrase? Practice going from the name to the bond line formula. I don't know why I just totally forgot that. Okay, and then the next thing we're going to do is the Newman projection. Actually, before we do the Newman projection, I do want to say that if we were naming this now that we have learned actually about R and S configuration, this right here is a stereocenter, and so we would have to state whether that was R or S. And so if we're doing this now, you would need to be able to say if it was R or S, and I'll go ahead and just work it out. Let's see, this would be 1, this should be 2, and this should be 3. So it would be, this would be R, but we need to flip these to get it there, so S. So I would find this as S configuration. So the true name is S2 iodo 1 butanol, or S2 iodo butan 1-all. Either of those would be correct. But I didn't have you guys do that yet because you obviously hadn't learned that yet. Okay. So now let's talk about the Newman projection. I'm actually going to go ahead and make the structure just so that it's easier for you to see. I'm going to make the ethyl group just, okay. I won't make that. Guess I can pause this. You can imagine the SpongeBob 5 minutes later. I actually never watched SpongeBob, but a podcast I listen to makes that joke all the time. Okay, so here I'll pull up one that I haven't drawn on all over. So I think we can agree that this is a same structure. We have the alcohol, carbon, 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 carbon. So we've got our 4 carbons to make the butane, the alcohol. The iodine is going into the page, so that's why it's a dash. And the hydrogen is coming towards us, and then there's 2 hydrogens here. I'm going to ask you real quick, would you have to name the R or S configuration on this? The answer is no. This is kind of a test for the next chapter because there's 2 hydrogens, so it's the same thing. So I only included the wedges and dashes here to help you visualize it for the Newman projection. You did not have to name those hydrogens, and you didn't have to do the RRS. You wouldn't have to do the RRS configuration on that. So the Newman projection, now you're allowed to have your modeling kit on your quizzes and tests. So you could have just done this to get it if you wanted to. So I'll go ahead and draw exactly what I see here, which is, I'll do the two in different colors. So hydrogen, hydrogen, and then the alcohol on the bottom. And then the back one has the ethyl group pointing straight up. I call this an ethyl group, even though it's part of the parent chain. I wouldn't name it that way, but just because that's what we're drawing, a CH2, CH3 sticking up here. I did see some people only write, like they would do their whole structure and they would just write C, but you do need to draw or write out the whole thing, CH2, CH3, or you can do the bond line. And then let's see, down here we have the hydrogen, and right here we have the iodine. Okay, so this is the right structure. So I drew this based on my 3D structure here. But if you want to practice, and I made sure to go from carbon 1 to carbon 2, right? But if you wanted to do it on your own, what I imagine is that I'm standing here and looking at it, right? There's my eye. And if the hydrogen, so like imagine halfway through this pin is the plane of the page. If the hydrogen is a dash going into the plane of the page and I'm looking at that, then it's on my left. So there's a hydrogen on my left, and then the hydrogen coming out towards me, if I'm looking straight at it, would be on my right. So that hydrogen is on my right, and then the alcohol is coming straight down. And then on the back carbon, and I'll do the back carbon in a different color, the back carbon has this, if I'm looking at it, the hydrogen is coming towards me. So if I turn it sideways, it's on the right. And it's pointed, and it's pointed slightly down. And then the iodine is going into the plane of the page. So if I'm looking at it, it's on my left. And then the ethyl group is coming straight up. So that's 2 different ways you can do it. Another mistake I saw people making that I want you not to do because it's too confusing is I saw people doing lines to the back carbon as well. You don't need these lines to come inside the circle. See how my line starts at the outside of the circle? That's how Newman projections are drawn. So I don't think I counted off points as long as you got your structure right or whatever, but I will in the future. You have to draw in the convention or people won't be able to understand what you're talking about. So first I just drew this basic Newman projection, and then I identified the 2 largest, because the instructions are to draw the Newman projection of the most stable and the least stable conformer, looking down carbon 1, carbon 2. So I did carbon 1, carbon 2, and then this handily tells you that iodine is larger than ethyl because it's lower in the periodic table. So my 2 largest groups are iodine on the back carbon, and alcohol is the largest group on the front carbon. So you just need to identify the largest group on the front carbon and the largest group on the back carbon. So I want these to be opposite each other. So, and I'm going to show you two different ways you can do it. You can either rotate this first one to get the alcohol over here, the hydrogen here, and this hydrogen here. So your alcohol has moved down here to up here. This hydrogen has moved here, and this hydrogen moved down here. But I didn't move the back carbon at all at this point. The back carbon is still the same. And so you can see the, this is iodine, not hydrogen. You can see the iodine and the alcohol are opposite each other. So this is anti, and it's also staggered. So if you drew the correct Newman projection, I gave you 2 points for that. And then if you got it anti, I gave you 1.5. Oh, wait, no. If you got it anti-staggered, I gave you 1.5 points for that. But if you only got it staggered, but you didn't have the largest group anti, I gave you 0.5 for that. So the other thing you can do is instead of moving the front carbon, you can move the back carbon. So you would need to move this here and this here and this here. So if you did that, your front carbon would stay the same as it was originally. And whichever one makes more sense to you, it doesn't matter. They're both correct. I would count both of these right. And then your back carbon would have your iodine had moved to the top. And you have to keep this in order. It has to be iodine, then ethyl, then hydrogen if you're going clockwise. Because if you don't, if you switch to, then that makes it to where you've changed the enantiomer, right? If you change out 2 of these, you've made it go from R and S, so it's a different molecule. So you have to be really consistent when you're doing your Newman projections to not flip those. Okay, and then, so that is also anti-staggered. So either one of these, or if you did it another way, I counted that right. If you did flip your, some of you, I saw this, and for some reason, it was like consistently if you had the alcohol pointing up. I don't know why, but if the alcohol is pointing up, you can do it that way if that is easy for you to visualize, but you still have to keep everything in the right order. So the back carbon then would have your hydrogen on the left, your iodine on the right, and your ethyl group down here. But I saw several people who had switched these 2 groups. So I just want to make sure that you don't flip those 2 groups, because if you have your hydrogen down here and your carbon here, then that's a different enantiomer, right? We've changed. You had to break those bonds to make that happen. So I just really want to encourage you, if you got minus 0.5 because you switched 2 groups, to make sure that you're not making this mistake. I think that you're going to have a question like this on your exam as well, just to kind of reinforce it, since I saw some people struggling with those little details. Okay, and then for the least stable, I saw some people put the big groups together like staggered, but actually the least stable is going to be eclipsed. And you want it to be what I like to call fully eclipsed, where your biggest groups are covering each other. So you only have to move the iodine slightly over from here. And then this hydrogen goes slightly up. And then this ethyl group goes over here. So some of you, I could tell that you meant this, but your groups were kind of far apart. So make sure that you're covering it up. Oh, wait. This should be a hydrogen, not an alcohol. I don't know why I put an OH there. So try to be sure that you get all those little details right, so that there's no question about if this is eclipsed or not. I just kind of gave you the benefit of the doubt. So again, I gave you 1.5 points if you got the big groups covering each other. If you got eclipsed but not the biggest groups, I gave you 0.5 points. And then if you swapped 2 of these, I took 0.5 away from the proper Newman structure part of it. Okay. Actually, I think I can get a clean one. Explain in your own words why cyclohexane takes a boat conformation instead of a planar hexagon shape. When I was grading this, I realized that some of you interpreted this as chair, just like probably without thinking. I didn't really want to count off points for that. I felt like, oh yeah, that kind of makes sense because they're thinking of like the most stable conformation. So I graded generously on this. And if you answered as a chair or a boat, I gave full points. But what I really wanted to see was a full explanation. So, like, if I were to write this out, I would say cyclohexane does not take a planar shape because there is ring strain resulting from torsional, or you could be like from the eclipsed hydrogens, torsional strain and some from angle strain. And then I'll say, but less from angle strain. And then I would probably say by bending into boat or chair, I would have taken either one. The torsional strain is relieved, though it may make angle strain worse. Overall ring strain goes down. And that's kind of what I was looking for, like, or even if you're like, because there's ring strain, which results from electron clouds interacting with each other. You know, I was open to a lot of different ideas, but I don't think anyone hit all these points, that there was like ring strain. Maybe a few people did, but there was ring strain, torsional strain, and then, you know, by bending, it relieves some of that. If you got the main ideas, I gave you, let me think. I graded the exam question that was reasoning after this. But this, so this is what's called a reasoning question. And I guess I wanted a little bit more of like cause and effect. So it felt like a lot of you were stating facts that are true, like chair or boat has less strain, and you would just say that. But it's like, why is it better for it to be less strain? Oh, the other thing I wanted you to talk about is being ring strain go down, making it more stable. Sorry, it's hard to like think about what my answer to this would be and also talk out loud. More stable conformation. So it was like I wanted you to do the cause and effect, kind of like, because it bends, it relieves these kinds of strain, and therefore it's more stable. And instead, it just kind of felt like people stated facts. So when I ask these kinds of questions, I really want you to do like full explanation and reasoning. And similarly on the exam, I asked why cyclohexanol, and I'll do this when I do my exam video, but why cyclohexanol is, or which one is less acidic or more acidic, cyclohexanol or phenol. And a lot of you are like, oh, it's phenol because of resonance. But not very many people took it one step further and explained, well, because of resonance, it's able to delocalize these electrons, therefore making this more stable overall after it's lost a proton. I want that level of cause and effect. And obviously, I grade generously and I include bonus points so that people can understand, like, or so that people have the chance to improve those skills and they're not dinged too much for it. But so on this one, I think if you got most of it, I did 4. If you like said at least one of my buzzwords that I was looking for, I gave half. But I tried to grade generously on this. And most people, because this bonus point was related to this, a lot of people actually made up a lot of points on the bonus for this. So, okay. And now the next one is the most stable conformation of cis-1 bromo 2-tert-butyl cyclohexane. So first of all, the most stable conformation of cyclohexane is chair. That's another reason I was worried people would say chair here. And then we have I like to just draw out, there will be 3 things that are pointing up that are axial, 3 things pointing up that are equatorial, and then I'll go to my equatorial ones and point down here. Okay, so all the blue ones are cis to each other, all the pink ones are trans to each other. So if it's easy for you to visualize it this way, which, hey, more power to you, it's kind of hard for me to visualize this way, I would just pick 2 pink ones and say 1 bromo and 2 tert butyl, because they're cis to each other, cyclohexane. That's the most stable conformation. So it's in the chair. And then I also very on purpose put the tert butyl, which is the bulkier group. This is like a quintessential bulky group because it's carbon with 3 hydrogens around it. So it's like kind of freaking huge. This goes into the equatorial position. And in fact, it goes so much, it's so big and bulky, and it's so hard to get it back into the right conformation after this that it will, it almost never goes into axial. It stays in equatorial almost all the time. So that's one way you could do it. If you can just like draw this for yourself and see like, oh, these 2 are cis to each other. This is cis 1, 2. Great, no problem. One's axial, one's equatorial. If that works for you, that works for you. I'm so happy if that works for you. Typically, that doesn't work for me. What I do instead is I start here and say axial, equatorial, axial, equatorial, all the way around. And then I do my, the ones pointing down. This would be equatorial. This would be axial. It doesn't really matter in this case because they're both cis. So you can just pick 2. And then I picked this axial and equatorial. So then I draw my chair. And I have my axial bromine here, and I picked bromine to be axial because it's smaller, and my equatorial tert butyl here. So a lot of you, if you put them in different positions than just the 1, 2, that's fine. I do it this way, but I obviously can see, I can grade it if you put it anywhere on the ring. It doesn't matter. But you have to make it very clear what's axial and what's equatorial. There's like these specific positions that are axial and equatorial. So there has to be 3 that are clearly pointing up axial, 3 that are clearly pointing up equatorial, 3 that are clearly pointing down axial, 3 that are clearly pointing down equatorial. And I tried to give you the benefit of the doubt if I couldn't 100% tell, or only take off a little bit if it seemed like you did 2 equatorial. But this is the right answer, and I'll grade more intensely on this on your exam. Okay. And then the 2 types of ring strain present in cycloalkanes is just torsional. If I could tell you meant torsional, I just gave you credit. Or one person had it like really off, and I was like, I think you meant torsional. It started with a T. I'll give you half points. Torsional and angle strain make up a ring strain. Okay, I hope that was helpful to you. If you have any questions for me, let me know, and I'll do my best to answer them. Happy studying.